Problem one, we want to solve triangle ABC given this information. So we have three sides, which means we're looking at a side, side, side triangle. So we just need to solve for each of the three angles. Now, I think I've given out the hint before that anytime we start with three sides and we have to solve for our angles, we should always solve for the largest angle first, which means solving for the angle that's opposite the largest side. Since if there is an obtuse triangle or an obtuse angle, that being an angle that's larger than 90 degrees, the law of cosines is going to pick that up because a cosine inverse can give us an answer that's in the second quadrant, whereas sine inverse only gives us answers that are in the first quadrant. So if we started for something that wasn't the largest angle first, we might end up missing it if we don't use the law of cosines. But all that it's just a complicated way of saying solve for the largest angle first. So if we go to our law of cosines formula, c squared is a squared plus b squared minus 2ab cosine of c, where c is the thing that we are looking for. So could solve that around and say that cosine of c is equal to a squared plus b squared minus c squared all over 2ab. Right, we'll just swap the 2ab cosine c and the c squared from each side and then divide by 2ab. So in the end, what actually needs to go into our calculator? C is equal to the cosine inverse of 3.1 squared plus 5.2 squared minus 7.3 squared all over 2 times 3.1 times 5.2. And we'll throw that into a calculator. So I want the arc cosine of a numerator divided by a denominator, close some parentheses, tell it it should be in degrees. Uh, 3.1 times 3.1 plus 5.2 times 5.2 minus 7.3 times 7.3. All that divided by 2 times 3.1 times 5.2. Hit an enter button and wonder, oh, I hit an S instead of a 2. Okay. I got 121.1 degrees. Rounding to the nearest tenth. Since it does say plus or minus 0.01 decimal or 0.1 decimal place accuracy. So we've got C. I'll put it in the box. Right. Next, I need to solve for one of the other angles. Looks like maybe I should shrink that down just a little bit. If I wanted to take this another way, I just solve for B next. And using basically the same operation that I just had in my calculator, but changing a couple of pieces. I could say that b is the arc cosine of 3.1 squared minus 5.2 squared plus 7.3 squared. All of that over 2 times 3.1 times 7.3. Right, I'm basically just switching out side B and side C. Uh, that being the only difference between calculating C and calculating B. Just makes it, I think, a little easier since you're using a calculator. You just go back and edit the equation you just put in. So let's see what we get if we do that. Change that to a minus sign. Change that to a plus sign. Change that to 7.3. I came up with 37.6 degrees. So we'll go ahead and put that in the box as well. And then lastly, where we've got space, looks like it's up at the top. We've got to get A. And here we'll take that A is just the difference between 180 and the other two angles, 121.1 degrees minus 37.6 degrees. And what do we get? 180 minus 121.1 minus 37.6, 21.3. So we'll also add that to the box, 21.3 degrees. And that's what that problem looks like, all solved. Alternatively, instead of doing the 180 minus the sum of the other two, we could have done yet another arc cosine function to get A. This time just making the 3.1 squared negative and having 5.2 and 7.3 in the denominator. And yeah. I have someone in the chat saying they're getting slightly different answers from what I got. So let me double check. Double check what I typed in. 5.1, 5.2, 7.3. Did I write down all the numbers right? I did. So I think these answers are correct. At least it looks like it as I review my work. So if someone else says they're getting a slightly different answer, I'll take a look at it all again. But these should be correct. Of course, now after I say all of that and then I post this video later, I'm going to get a bunch of comments about it. But hopefully I just unjinxed myself. Hard to say though. So what is next? We want the area of this triangle. We have a few different options for area. So there's the method that was on worksheet 13 that involves two sides and the angle in between them. Or there's the method that's on worksheet 14 that involves that semi-perimeter S. And since we were given all three sides, I'm going to use that equation. But I could have just as easily used one of the other ones instead. So that semi-perimeter should be 3.1 plus 5.2 plus, hey, 7.3 all over 2. And what happens if we plug that in? It's going to be 0.6, 15.6. Oh, wait, but over 2. So it's 15.6 over 2. It's nearly 8, but 0.2 less. So 7.8. Yeah, cool. So I think that's S. Then the area should be the square root of 7.8 times the difference between 7.8 and every other side. So if I subtract 3.1, I get 4.7. If I subtract 5.2, I'm going to get 2.6. And if I subtract 7.3, I'll get 0.5. And we can take all that and plug it into a calculator. So what do we have? 7.8 times 4.7 times 2.6 times 0.5. All of that to the 0.5 power. I get 6.90 square feet. Haha, it's just a handy trick of move the whole thing over so it backs up right into the answer box. Look at that. And so again, you could have used one of the other formulas that involve like 1/2 AB sine C, any one of those from worksheet 13 and gotten just this answer as well. Okay. So problem 2. Solve the triangle given the following information. Side A is 11.4, angle A is 58 degrees, and side C is 12.8, where those distances are measured in meters. Now, because we're given 2 sides and one letter is repeated, right? We have letter A shows up twice. This means it's going to be one of those side-side angle triangles. Where we're going to have to check for a second triangle. Because I'll recall that there are 2 different types of triangles we could have if we're given 2 sides. In the case where letter is repeated, like this one, because letter A is repeated in the given information, we will have to check for two for 2 triangles. And also we're going to start with the law of sines. The other version where we're given 2 sides and the angle that's in between them, meaning that we know one thing about each letter A, B, and C. That only has one triangle associated with it, and we start with the law of cosines. So anytime we work with the law of cosines, there's only ever going to be just the one triangle. But if we work with the law of sines, there is a possibility for 2. So for this one, we're going to have to use the law of sines to start by solving for an angle, which is where that ambiguity will come from. So enough dilly-dallying. Let's solve this thing. I've got sine of angle C divided by 12.8 is equal to the sine of angle A, which is 58 degrees, divided by 11.4. And then this will give us that sine of C is equal to 12.8 divided by 11.4 times the sine of 58 degrees. And here is where everything should split. And there's a big answer box that's going to get in the way. So hopefully I'll have enough space to get everything down. So I'll start with C1, which is equal to the arc sine of everything that's on that other side, 12.8 over 11.4 times the sine of 58 degrees. Put the given information on there as well so we can see that all in one spot. And we'll take that to words. We'll take that to a calculator. So arc sine of 12.8 over 11.4 times the sine of 58 degrees. And I'll want that in degrees. I came up with, 72.2 degrees. So that'll be my angle C1. And when we go back and check for C2, this is the step we're going to come back to. But for starters, let's finish solving the first triangle. Next, we should get angle B1. Which ought to be 180 degrees minus angle A minus angle C1. So this will be 180 minus 58 minus that angle we just got, 72.2, 49.8 degrees. And now that we have that, we'll look for side B1. So B over 49.8 is equal to A over sine A. So 11.4 divided by the sine of 58 degrees. And here I'll just come back to the given information because both my answer will be more accurate and if there were any mistakes there, they aren't going to carry through since I'm coming back to the given information. So that means that B1 is 11.4 times the sine of 49.8 degrees divided by the sine of 58 degrees, which comes out to a number. Let's go find out what it is. 11.4. Yeah, let's do this in a new tab. 11.4 times the sine of one thing divided by the sine of another thing. That thing on top is the sine of 49.8 degrees. The thing on the bottom is the sine of 58 degrees. That's going to come out to 10.3. And we should probably put some units on here. Meters. So M for meters. So cool. That's our first triangle. Now we're going to come back up and solve for the second one. So angle C2, then it should have C1 as a reference angle. So it is 180 degrees minus C1, which comes out to 107.8 degrees. With that in mind, we now start the whole process over, and we solve for B1, or for angle B2 and side B2, the same way that we solved for angle B1 and side B1, but we're going to substitute this angle C2 in instead. So angle B2 is going to be 180 degrees minus A. So we always have to come back to A. That's the given information. Minus C2. And we can see what we get here. Change 72 to 107.8. 14.2 degrees. And then we'll come to solve for side B2, where I'm going to take this piece and paste it back up here. 11.4 times the sine of something divided by the sine of 58 degrees. All of that is related to A, so it doesn't change. The only thing that should be different between the two is this 11, or not 11, 14.2 degree angle right there. That's the only piece that changes from my calculation from B1 to B2, because instead of using angle B1, I need to use angle B2. And all of my information about A remains the same because A was the given. So we can pull up that same entry in our calculator, but change 49.8 degrees to 14.2 degrees and come up with 3.3. And again, in meters. Can I draw what this triangle would look like? Yeah, I should be able to do that. Let me just put all these answers in the box real quick. C1 is 72.2 degrees. B1 is 49.8 degrees. And side B1 is 10.3 meters. Oh boy. Touchscreen's going a little wild. Okay, and then angle C2 we said was 107.8 degrees. Side B2 is 14.2 degrees. Or angle B2. I think I just said side B2. Well, either way. It's a good thing I edit all these before I put them on the internet, said the liar. Okay, cool. So if we wanted to draw what this triangle would look like, let's come on over here to the start. So my method for drawing out one of these kinds of triangles. Start with just a horizontal line, like so, and then usually in the left corner, but you can do it in either spot. Well, I guess this is my method for drawing out what a crazy two triangle thing looks like. So always start with a horizontal line, then draw the angle that you're given. We have a 58-degree angle. And this is an actual side length, so I'm going to fill it in a solid black line instead of the pencil line. And start labeling what we have. This is angle A, meaning I have a 58-degree angle. Now, the two sides that are attached to angle A must be sides B and C. I always know that side A is opposite angle A, so these two sides must be B and C. Uh, whatever side I am given is the one that I just drew in because it's got a fixed length, as opposed to that horizontal line, which doesn't have its own length yet. It's just a line. I know what direction I want it to go, but I don't know how long that direction should be. So I'm going to put the other piece that was given. That was angles, or that was side C, which was 12.8 meters. So I'm going to put 12.8 right there. Now here's where things get a little bit tricky. I don't know angle B, which angle B is going to have to be up here, right? Because it can't be the other angle, because the other angle that's kind of over in this general region, that's going to have to be angle C, because that's now opposite side C. I guess I should have circled it in green, because that's where side C should go. So I don't know what angle B is, which means that B could continue going away from angle A, or it could cut back toward angle A. So I'm going to have two different options uh, for this side over here. All I know is how long this side is. I know this side must be 11.4 because it's going to be side A. And like I said, I could venture out this way from angle B. Yep, venture out away from angle A that I've already drawn in. Or I could venture back inward. And let's move that label over there. And now drawn here, those are going to be my two triangles. Oop, let's try that again. Where I know both of these two lines that I just drew are going to be 11.4 meters long. And if I take a look at this angle here, the one where I cut away from angle A, let's try and make that an actual straight line. This is going to be my angle C1. And this angle over here should be my angle C2. This angle right there, that's C2. Meaning that this longer side length that comes all the way out is B1, while this little guy is B2. And that's what our two triangles would look like. One of them is a very skinny triangle, and the other is a more, I guess, normal looking triangle. Doesn't really make sense, but let's pretend like there's a normal looking triangle. The first one maybe looks more normal. Don't really know exactly what I'm trying to say there, but hey, whatever. So those are our two triangles. Now, after that super long-winded explanation, let's talk about what's actually going to show up on the exam, because that's, tomorrow at the time of this recording. But maybe that exam is right now, if you're taking it and watching this video at the same time. The pro strats. Um, on the exam, there are only going to be 6 points in total out of 100 about two triangle problems. So one of them will be a basic question about identifying how many triangles you have based on some given information. Your answers will be 0, 1, or 2. And I guess the hint I'll give is that if I ever ask that question, the answer's never 1. Could be 0, but it's probably 2. So there you go. You got a 50-50 shot right from there. And then the other question I'll ask for is that I'll tell you explicitly on another set of information that there are two triangles. And I'll simply ask you for the two possibilities for the first angle. So if this given information were on the exam, it would be two questions. One would be, how many triangles are there? 0, 1, or 2. You would say 2. And then the second question would ask only for C1 and C2. So I'm just going to ask you to provide those two angles. And it'll be one of those multi-select kind of problems where there will be multiple angles, and you have to pick the two correct answers. And you'll get points for each one that you get and lose points for each one that you don't get. Good plan, great plan. All right. Cool. So, number 3, we got a word problem. Coast Guard Station Brave is 47 kilometers due north of Coast Guard Station Courage, and an airplane is forced to make an emergency water landing and is sighted at the sighted by the Coast Guard stations. And if you'll notice, the naming scheme that I gave to these stations and the airplane makes a very nice B, C, and A for this triangle that we're going to label. So let's get to it. We know that we have one Coast Guard station that's due north of another, and this plane is going to be somewhere to the northwest. So let's get our ruler back out. Come on now. Okay, so there we go. We can have a line that's going to be due north. We know that one sighting is going to be roughly 57 degrees. We know it's 57.4 degrees to the northwest, but my ruler doesn't do, small divisions of angles. So I'm just going to set it to a 57-degree angle. No, slow down. That's not how this works. Right, because that's 90 degrees straight up. Yeah, so if I want to come to the left, that's not how that angle would look. That would have been 57 degrees measured from a horizontal line. We need 57 degrees measured from the vertical line. So let's try that one more time. 90 minus 57 is 33. So we actually wanted a 33-degree angle here. We'll draw that line out. And then we have a 32-degree bearing. So if we go to our 90 degrees and turn 32 degrees to the northwest, that'll get us to 58 degrees. Match that up to the bottom Coast Guard station. Oh, man. And hey, look, I drew that first one near about perfectly. Fancy that. So, what did we know? Brave is due north of Courage. So, Coast Guard Station Brave is going to be that one. Courage should be that one. And then we have an airplane, conveniently labeled A. That's going to go up there. All right, and in the end, what did we actually want here? Well, for starters, we wanted that line to continue just a little bit to the north. So we can label our bearings. We want to know how far the downed airplane is from Courage, which means we're hopefully trying to get that distance, B, which is the distance between A and C. If we label the bearings on here, this angle, we saw a moment ago, it's only 57 degrees, but we'll label it as 57.4. And down here, this bearing angle is 32.1 degrees. All right, so now that we have those bearings labeled, the last piece of given information was the distance between those two Coast Guard stations. And we know that it should be 47 kilometers. So we'll put a 47 right there. Now, ultimately, we're solving for the length of side B. Before we get there, we should finish filling out any other information we can, like angle B, which we know should be 180 degrees minus that bearing angle. So that's 57.4 degrees. And what does that come out to? 122.6 degrees. And now that we have two of the angles that are inside that triangle, so we know that this bearing angle is the same as angle C. We should be able to put all that together to get angle A. It should be 180 degrees minus 122.6 degrees minus 32.1 degrees. If we put all that together, what's left over? I'm just going to take this to a calculator before I mess it up. 180 minus 122.6 minus 32.1, 25.3 degrees. So now that we have all of those angles put together and we know at least one side, we should be able to use the law of sines to get that missing side length, B. So B divided by the sine of angle B, which is 122.6 degrees, should be equal to 47 divided by the sine of the angle opposite it, which is 25.3 degrees. Meaning that in the end, B is 47 times the sine of 122.6 divided by the sine of 25.3, which that is something I'm definitely not going to be able to calculate in my head. 47 times the sine of something divided by the sine of something else. 122.6 degrees divided by 25.3 degrees. I get 92.7 kilometers. Haha. Cool. 92.7 kilometers. Let's just make sure we got the, yeah, we only needed accuracy out to the 10th place. Not that it matters on a, multiple choice exam, because all the answers will already have their accuracy predetermined, but we might as well follow the instructions given. Okay, problem 4. Calculate the area of the triangle given. Well, we know side A, angle B, and side C, which looks like we probably just want to use one of the formulas from worksheet 13. Specifically the one that's 1/2 CA sine of B. So 1/2 of a number times the sine of an angle, or I can plug all that in. 12 in for A, 4 in for C, 81 degrees in for B. And we'll get fancy with it again. We should be able to plug all that into a calculator. That's going to come out to 24 sine of 81 degrees. I'm coming up with 23.7. when I plug that into a calculator, and that should be in square centimeters. Next on to problem 5. Find the exact value of the following. Show all work. Simplify any radicals used. So let's start by looking at 3 pi over 8, which should be in quadrant 2. And also note that 3 pi over 8 is the same thing as 1/2 times 3 pi over 4. So that anytime we've got a something pi over 8, we're probably going to be looking at a half angle formula. In this case, we're going to want the half angle formula for sine, which is plus or minus the square root of 1 minus the cosine of 3 pi over 4 divided by 2. Now, we are in the second quadrant because, oh, wait, hold on. Well, that's embarrassing. 3 pi over 8, that's definitely in the first quadrant, not the second quadrant. So quadrant 1. Not that it makes a difference for sine, because quadrant 1 and quadrant 2 are both positive. So it's a mistake that wouldn't have cost me points, which is nice, but a mistake nonetheless. So yeah, 3 pi over 8 is in quadrant 1 because 3 over 8 is less than 1/2. That's usually my trick for figuring stuff out. So I just look at the coefficient on pi and relate it to, 1/2, 1, 1.5, and 2, since those are the boundaries between quadrants. So I've got all that set up. I'll go to plugging in a value for the cosine of 3 pi over 4. So this should be 1 minus negative root 2 over 2. Since 3 pi over 4 is in the second quadrant and cosine is negative there, all of that is over 2. And then we'll go through the process of simplifying that. So this will be the square root of, let's just come back up here, multiply by 2 over 2 will give me 2 minus the square root of 2 all over 4, square root of the whole thing, which means that it can simplify to the square root of, oops, that should have been 2 plus the square root of 2 since there's a double negative there. So 2 plus root 2 all over 4. So this will simplify to the square root of 2 plus the square root of 2 all over 2. Let's see. Can I make this fit into the box conveniently? Maybe with just a little bit of... it's not going to be the easiest thing to do, is it? I can get that to go right there. Maybe if I stagger things, it looks all right. Aha, cool. All right. Problem 6. Not featured in spring semester 21. So this is from worksheet 11. Which is bonus content this semester. And by that, I mean it's not on quizzes or exams, so we don't need to worry about it. So moving on to problem 7. Given that the tangent of u is equal to negative root 39 over 5, and u is in between pi over 2 and pi, we're going to look for the exact value of cosine of u over 2. Oh, and that's it. Thought I was asking more questions. But for starters, we're going to want to make ourselves a reference triangle for u. Notice over here, it tells us u is going to be in quadrant 2. U is in quadrant 2, so I'm going to put this one in blue. So we should make a reference triangle. Like so. There's our angle U. And what else do we need? We're gonna want an opposite and an adjacent side. Tangent is opposite over adjacent, so root 39 goes here, while 5 goes down here. We're in the second quadrant, so the adjacent side should be negative. And then we'll use the Pythagorean theorem to get that the hypotenuse is 8. 39 plus 25 is 64. Square root of 64 is 8. So we're also going to need the quadrant of u over 2. So if we multiply that inequality by 1/2, we get pi over 4 on the left and pi over 2 on the right, with u over 2 in the middle. Meaning that u over 2 is in quadrant 1. So I think that's enough information for us to go solve for the cosine of u over 2. From the formula, we know that it is plus or minus the square root of 1 plus the cosine of u over 2. And we're in the first quadrant, so we're going to choose the positive value. So this will be positive square root of 1 plus cosine, which is negative 5 over 8. All of that over 2, which becomes the square root of this will be 8 minus 5 divided by 16, which simplifies to the square root of 3 over 4. make it clear that that is a 8 minus 5. All right, and I think we've got just this one last problem. Well, we'll find out later when that last page eventually loads, but I'm pretty sure that's just a formula sheet. So before I get too far ahead of myself, I have a question. Wouldn't I multiply the 8 to the 5 as well? And not, well, we did, but it sounds like not in the way that you were expecting. So the operation that I took back here was to multiply by 8 over 8. And when I multiply the 8 to the 5, that's multiplying 8 into 5 over 8. So the 8's reduce there, leaving me with just minus 5. So I did multiply the 8 into the 5, but it was already a fraction. So it didn't impact the 5 part. It just reduced with the 8 that was already there. In fact, it's because 8 is the denominator there that I chose to multiply by 8 over 8. Because I'm trying to get rid of, I have a fraction within a fraction, and I'm trying to not have that. So I multiply by the denominator of this fraction within the fraction so that I just have a single numerator and a single denominator. Okay. Okay, hey, look at that. Not that anybody watching the video can see what I'm mentioning, but that's just for us. All right, problem 8. Find the exact value. You must show the following, including a reference triangle. So, since we're bringing up a reference triangle, usually I've been doing alpha in red. So let's keep alpha in red. So, let's try it one more time. So the solution to an inverse sine problem, or arc sine, whichever one you feel like using, is just an angle. So when we take the sine inverse of negative 11 over 61, our result is an angle, which means we are looking at the tangent of alpha minus pi over 4. And we know that there is a formula for that. Specifically, the tangent difference formula, which I believe says it's tangent alpha minus tangent pi over 4 divided by 1 plus tangent alpha tangent pi over 4. So if I knew tangent alpha, I'd be all set. Since this thing comes out to something minus 1 divided by 1 plus something times 1. Don't forget tangent of pi over 4 is 1. So I've just got to figure out what that something is. Again, it's tangent alpha. So let's go make ourselves a reference triangle. Our reference triangle should be in the 4th quadrant because I'm taking the sine inverse of a negative number. Let's try and make a slightly more reasonable triangle based on the given information. We have sine inverse of negative 11 over 61. So negative 11 is the adjacent side, 61 is the hypotenuse. Then either use the Pythagorean theorem or your knowledge of Pythagorean triples to find that the missing side is 60. Because we'll take 61 squared minus 11 squared. We should end up with 3,600, the square root of which is 60. Yep. So it's a positive 60 because it's in the fourth quadrant. But we wanted the tangent of alpha, which should be opposite over adjacent. So negative 11 over 60 instead of negative 11 over 61. And then we'll just get this thing to look like one of the multiple choice boxes. In order to do that, we'll multiply by 60 over 60, clear out our extra denominators. That should give us negative 11 minus 60 divided by 60 minus 11. Which in turn, that's equal to negative 71 divided by 49. All right, and now I think that should be the end. Yep, that last page is just a formula sheet where we can find all of the formulas that we used throughout. So the things that we used in this one, I know we just used tangent of u minus phi. Doesn't seem like we used any of the sine or cosine sum and difference formulas, but I know we came to use both sine of u over 2 and cosine of u over 2. Those both came up. And then we just used everything in the last few boxes. Specifically on this practice exam. We'll use a bit of everything on the real exam, but this is what we used a lot of on this practice exam. Yeah, so it's all right there.